Good evening. Today I have a fun one, I think. I want to talk about Y2K. I want to talk about what the problem was, why people thought it was going to be such a big deal, and a few maybe predictions of what kind of problems either could have been seen if the problems weren't fixed in advance, or were probably seen in some places. So what am I talking about when I say Y2K? Well, back in the late 90s, there was concern over the way some computer software had been written. A large amount of software had stored dates with only 2 digits for the year. For example, they were storing the year 2018 only using the last 2 digits. And the reason behind this was fairly sensible. Storing 2 digits of a year can sometimes be half the size of storing the whole year if you're storing those digits individually. But the whole thing was a little bit short-sighted, and when 1999 flipped over to 2000, the worry was that many computers all over the world were about to think time had gone backwards by about 100 years, because that's how they'd been programmed. They were assuming dates started with 19, so to them it was going to look like the date was now 1900. And this is a little problematic. You can imagine if you ordered a package online and the delivery system thought that the package was going to be delivered 100 years earlier, it would probably show you some confusing information if you have any kind of appointment. Again, it would show you confusing information. It would probably show you that either you were... actually, this is a kind of a fun one. Imagine you borrowed a book from the library on December 24th, 1999, and it's Christmas, so you spend time with your family and you don't really think about it. Then, all of a sudden, when the 1st of January 2000 rolls around, all of a sudden it looks like you have borrowed the book and taken it back in time. And I can imagine some overcharge, some kind of late charging systems might get confused by this and report that the library owes you many millions of pounds or dollars. That's kind of theorized. I imagine things like that probably did happen. Say if you were scheduled to borrow something at a certain date in 2000, then when the system chops this off, it's going to look like you borrowed it 100 years ago and you are extremely late in returning it. People were worried about aircraft as well. Booking systems and such probably get very confused when time suddenly jumps by 100 years. that's kind of that's the whole thing. There's nothing more complex to it than that. It's just the dates were being stored in this kind of lazy but space-saving way. We have another problem coming up called the 2038 problem. So what is the 2038 problem? For a long time, and still today in some cases, computers measure time as the number of seconds since the 1st of January 1970. That's midnight on the 1st of January. And for a long time this worked and made lots of sense. The problem is the number they use to store the number of seconds since that date is a 32-bit integer. And if the idea of a 32-bit integer doesn't mean anything to you, I recommend having a look at my bits and bytes video. But the maximum value you can store in a 32-bit integer is 2 to the power of 32 minus 1. And remember, the minus 1 is because 0 counts as a number. And it turns out that 2 to the power of 32 minus 1 seconds lands somewhere in 2038. I can't remember exactly where, but this is the 2038 problem. To kind of get around this and combat this problem, we've decided we don't want to do what we did with Y2K and wait until the last couple of years to try and fix all the problems that we have. We've gotten a head start on this and it's mostly fixed now. And the way that it has been fixed, or rather there are a number of ways that we fix this. The first one is store the number of seconds since January 1st, 1970 in a 64-bit integer. This is the simplest solution. It allows you to record time essentially forever. Like, I can't remember exactly when, but this is billions and billions and billions of years away. Given that this kind of naive solution is such overkill, instead of recording the number of seconds since January 1st, 1970, we have in a number of places decided instead to record the number of nanoseconds since January 1st, 1970. Now, a second has 1 billion nanoseconds in it, so we can still record time basically forever, but now we have much better accuracy, much more fine-grained time keeping. And this isn't the only solution that was come up with. There are a few other schemes that you can use. Some people have decided to store seconds and nanoseconds separately, for example. So, no, I can't remember the exact details of this, but I think they have something like 64 bits for the number of seconds and also 64 bits for the number of nanoseconds. So if you have, say, 1,000 seconds since January 1st, 1970, the nanoseconds component is the number of nanoseconds inside that second that have elapsed. And this is a little more future-proof, and it's intended for really kind of high resolution timestamp formats for when you really need very, very detailed time recordings. I don't think this is super widely are some big users of it. I think a bunch of large companies have adopted doing it this way. I also have a feeling that some programming languages have defaulted to that way of doing it as well. Lastly, I think I want to just spend some time spreading the gospel of ISO 8601. One of the things that we haven't addressed in all of this discussion of time is time zones, and boy, they are a big topic. The world is split into so many time zones, and there are some interesting misconceptions. For example, some people assume that time zones are all at hour intervals from each other, so +1, +2 for parts of Europe, -8, -6 for parts of the US. But it's not strictly true. There are some, for example, +45 minutes, -15 minutes. I don't think those two are actually real, but I think there are definitely time zones that are not on full hour boundaries. People also assume the world is split into chunks of time zones. This is mostly true, but it's not strictly true. It's not unusual to find random islands in the middle of the ocean that kind of force the time zone to move slightly. It's also not. It is possible for a country to adopt multiple time zones. I can't remember. I think there is somewhere in Australia. Don't quote me, but do look this up because it's interesting. There is somewhere in Australia, say it's Australia, where in some small chunk they observe a different time zone. But to make it even worse, there's a small chunk inside that chunk that decides to adopt the original time zone. So if you fly, if you fly across that chunk, you end up going through 6 time zone changes. So how do we represent time zones usually? Well, so ISO 8601. ISO stands for the International Standards Organization, and they come up with the agreements on how to structure various things, whether it's data formats or protocols for talking between machines or protocols for different programming languages and so on. They essentially record standards. And 8601 is by far my favourite, and I take every opportunity I can find to talk about it, which is why we're here. So ISO 8601 is a standard for representing time and dates, and it stipulates that the correct date format is year. I've already done it wrong. Year dash month dash day, then a T, then hour, minutes, seconds, nanoseconds, and then time zone, which for now I'll represent as a Z. So why this format? Let's write a date. 2018 01 01 at midnight. No nanoseconds and AZ. So, first question, why the Z? So Z stands for Zulu, or Zulu time, and it is another way of saying GMT or UTC, so it's no time zone offset. If you want to say plus 1 hour, you would put a plus, and then you say 0100 for plus 1 hour. If you wanted to say minus 8 hours, you could also just say minus 08. And that represents the time zone offset. The reason this is such a powerful way of representing time is twofold. One, it is completely unambiguous. There is no way of interpreting this in any different way than as an exact point in time. If you were to remove the time zone, for example, this no longer represents a point in time and is what's called a local time. Without the time zone, it's impossible to know what point in time this refers to. Additionally, this format will always sort nicely. So what do I mean by that? When you sort things alphabetically, or to use a slightly more strict term, lexicographically, they mean basically the same thing. Earlier numbers and earlier letters in the alphabet come before later ones. So if you imagine you sort from A to Z and from 0 to 9, if you were to sort alphabetically a whole bunch of dates, you also get the side effect of those dates being stored chronologically. As always, I thank you for joining me, and if you have any questions about date formats, I have opinions about this. I think that ISO 8601 is the one true date format. As always, thank you so much for joining me, and I will see you again